In the previous video, we derived the formula for the distance between a point and a line. In this video, let's see how we can use that in geometry. Here's an example. In a triangle with vertices A 2, 3, B 4, -1 and C -1, 4, find the equation and length of the altitude from the vertex A. Let's draw the figure. We have the x-axis, the y-axis, these are the points. 2, 3, that's vertex A. Then B is 4, -1 and C is -1, 4. So in this triangle, we are asked to find the equation and length of the altitude from the vertex A. Altitude means perpendicular. So this means this line is perpendicular to the base. So we need to figure out the equation of this line and the length of this line. Now pause the video, try this on your own. Okay, let's do this together. This is A, B and C. This point, the foot of the perpendicular, let's call it F. Note that we're not asked to find the coordinates of the point F. Now we can figure it out, but we're not asked to do that, so we won't find these coordinates. Alright, how can we still find the equation and the length? Let's focus on the length first. This is the perpendicular distance of this point from this line. So length of AF is equal to the distance of A from the line BC. And we can use the distance formula here, distance between a point and a line. So if this line, the equation of this line is this, AX plus BY plus C equal to 0, then using distance formula, this length AF is equal to mod of AX1 plus BY1 plus C. That's basically putting x1, y1 in the equation of this line divided by square root of a square plus b square. So we can figure out the length if we have the equation for BC. But do we have the equation for BC? Not yet. Can we figure it out? Absolutely. We have the coordinates for B and the coordinates of C. So we have these 2 points. We can conveniently use the 2-point form. So let's do that. Using 2-point form, the equation is y minus y1 by x minus x1 equals to y2 minus y1 by x2 minus x1. So we can plug in the values. Y minus -1 divided by x minus 4 equals to 4 minus -1 divided by -1 minus 4. So this becomes y plus 1 divided by x minus 4 equals to 4 plus 1, 5 divided by -1 minus 4, that's -5. Note that on the right hand side in the 2-point form, we're actually looking at the slope of this line. We need the slope later, so let's pay close attention to this. This is y plus 1 by x minus 4 equals to -1. Looking at the equation in this form tells us that the slope of this line BC is equal to -1. But let's continue. Let's write this in the standard form, because when we have this in the standard form, only then we'll be able to use the distance formula. So let's do that. Y plus 1 equals to minus x minus 4. This is y plus 1 equals to minus x plus 4. Bring everything on one side and put 0 on the other. We have x plus y. 1 minus 4 is -3. So this is x plus y minus 3 equals to 0. This is the standard form of the equation of the line BC. Now we can use this to find the distance AF. So let's do that. This is equal to mod of, instead of x we'll put in 2, instead of y we'll put in 3. So 2 plus 3 minus 3, mod of this divided by square root of 1 square plus 1 square. This is 2 plus 3, 5 minus 3, 2. So 2 in the numerator and root 2 in the denominator. 2 by root 2 equals to root 2. So we are halfway there. We've figured out the length of the altitude. That's root 2. Now on to the other half. We need to find the equation of the altitude as well. How do we find the equation? Well, we have a point. Do we have something else? We can find this other point F and use the 2-point form, or we can find the slope. And how can we find the slope? Well, this is the altitude, which means this is perpendicular to BC. If we know the slope of BC, we can figure out the slope of AF. And we do know the slope of BC, that's -1. And once we have the slope, we can figure out the equation of AF using the slope point form. So let's go ahead and figure out the slope. slope of AF is equal to -1 divided by the slope of BC. That's -1 by -1. That's equal to 1. So slope of AF is 1, which means now we can use the slope point form. So wrapping this up, slope point form, y minus y1 equals to m times x minus x1. The point is 2, 3. So y1 is 3 and x1 is 2 and slope is 1. So y minus 3 equals to 1 times x minus 2. Y minus 3 equals to x minus 2. Rearranging, y equals to x plus 1. This is the equation of the altitude from A for this triangle ABC. Let's solve one more problem. Find the points, plural points, which means there's going to be more than one. Find the points on the x-axis whose distances from this line are 4 units. So x by 3 plus y by 4 equals to 1. This is the line. And the points that we're looking for are on the x-axis and they are 4 units away from this line. So pause the video, try visualizing the scenario and then solving it. Alright, let's do this together. Let's assume that the points that we're looking for are h, 0. Because they're on the x-axis, we have the point as h, 0. We've taken one point h, 0. We'll probably get an equation which will give us more than one values of h. Okay, what is the condition that we have to satisfy? The condition is simple. This point is 4 units away from this line, which means the distance of this point from this line is 4. So we can use the distance formula. AF, that's equal to mod of AX1 plus BY1 plus C divided by square root of A square plus B square. Alright, let's convert this equation into standard form and then plug in h, 0. This is what we get. H by 3, x is h, plus 0 by 4 minus 1 divided by mod of this divided by square root of a square plus b square. That's 1 by 3 square plus 1 by 4 square. That's 1 by 9 plus 1 by 16. This is the length. This is the distance. So this is equal to 4. This is what we have to solve for h. So simplifying this, this is 0. This is h by 3 minus 1 or 1 by 3 common. 1 by 3 mod of h minus 3. That's the numerator. The denominator is square root of 16 plus 9, that's 25 divided by 9 times 16. So that's root 25 by 9 times 16. All of these are squares, so the root will be simpler to solve. This is equal to 4. So this becomes 1 by 3 mod of h minus 3 divided by 5 by 3 times 4. That's equal to 4. Now things are already cancelling out. 1 by 3 cancels out. We have 5 in the denominator and then 4 back in the numerator. So we can cancel this 4 out as well. This is 4 times mod of h minus 3 divided by 5. That's equal to 4. This 4 also gets cancelled. This 5 is what's left. So h minus 3 mod of this is equal to 5. This is the equation. Let's open the mod. If something mod is 5, this means that something could be 5 or that could be minus 5. So h minus 3 equals to 5. That's the first equation. H minus 3 is equal to minus 5. This is the second one. Both of these will give us values of h, which means we'll have 2 points on the x-axis that satisfy the condition. Solving the first one, we have h equals to 8. Second one gives h equals to minus 5 plus 3. That's minus 2. Which means our points are 8, 0 and minus 2, 0. Now, one last time, pause the video and try visualizing these points on the map. Try plotting this line as well and see why these 2 points make sense. Here's the visualization. This is the line x by 3 plus y by 4 equals to 1. The intercepts are 3, 0 and 0, 4. And these are our answers. These are our points on x-axis. Minus 2, 0 and 8, 0. This length is 4. This length is 4. You can see that this length is 5. This length is also 5. 8 minus 3 is 5. And 3 minus 2 is also 5. And you can also see that this length, these two lengths are 3. If you take 3 as the radius and draw a circle, you'll get these two tangents to this circle centered at 3, 0. So this is the solution. The points are minus 2, 0 and 8, 0.